Welcome to my projectbazaar.com. Now we discuss about the product for Parasitics-Aware design of symmetric and asymmetric gate work function FinFET SRAMs. Next we see the abstract for the product. SRAM is a form of semiconductor memory widely used in electronics and microprocessor and general computing applications. This form of semiconductor memory gained its name from the fact that data is held in there in a static function and does not need be dynamically updated as in the case of DRAM memory, while the data in the SRAM memory does not need refreshed dynamically. It's still volatile, meaning that when the power is removed from the memory device, the data is not held and will disappear. The operation of the SRAM memory cell is relatively straightforward. When the cell is selected, the value of to be returned is stored in the cross-coupled flip-flops. The cells are arranged in a matrix with each cell individually addressable. Most SRAM memories select an entire row of cells at a time and read out of content at all the cells in the row along the column line. Access the SRAM memory cell is enabled by the word line. The control to access control transistor which control whether the cell should be connected in the bit lines. These two lines are used to transfer the data both read and writing process and write operation. The most commonly used SRAM type of in the 60 SRAM which offers better electronic performance from the all aspects: speed, noise and immunity, standby current. The smallest 60 SRAM cell has been fabricated till today as an area of 0.08 micrometer square and 2 was developed in 20 nanometer technology based on our proposed designs. In this paper, a new approach how to towards the design of memristor based non-volatile static random memory access cell using the combination of memristor and metal oxide semiconductor devices proposed. Memristor and MOSFETs of the Taiwan Semiconductor Manufacturing based on 180 nanometer technology are used in the form of single cell. The predicted area of these cells is significantly less and the average of read-write operation power less than 25 times of less than the conventional 60 SRAM based designs in our overall memory architecture. The non-volatile characteristics of cell makes it attractive for non-volatile random access memory architecture designs. Next we see the flow diagram for the product. First we design the SRAM architecture designs and to apply the memory architecture design. This SRAM design does storage for the single bit storage cell for the two inverting cross connections results and to apply the multi-threshold swapped MOS designs to optimize the number of transistor level and to designs for the STT-MRAM architecture results. The STT-MRAM architecture is mainly used to cache architecture to design the fast temporary storage purpose using the STT-MRAM cache architecture. This result to this architecture to reduce the writing time and to reduce the writing leakage power for the overall read and writing operation for memory any type of memory architecture results and to design the low power consumption due to the write operation and to calculate the final timing results for read and writing operations. This designs to optimize the SRAM based architecture results and to optimize the STT-MRAM architecture. This STT-MRAM architecture mainly consider for the data storage block, transmission gating blocks and the sense amplifying results and the read and writing operation, then the sense amplifier. When the data storage is internally applied for your architecture and to optimize the writing processing time and to enable the read operations to reading the operation. This the VDD storage to be optimized for our the overall architecture process and to achieve the STT-MRAM cache application results for the overall architecturing functions. Finally we see the output for the product. First we design the STT-MRAM architecture designs for overall architecture results. And first we design the 60 based SRAM cell. This SRAM cell mainly used to store the data processor. Then go to the data storage for flip-flop architecture requirements. Then the transmission gate mainly used to port for the input and output analysis process for overall architecture designs. Then go to the read and writing architecture. The enable circuit to control the read and writing process. Whenever the writing cell to be activation to process the whatever the reading process for data required data input for given data input results, and two designs for sense amplifying architecture. The sense amplifying architecture to analyze the data transferring for the read and writing process and to display the final output results based on our the non-volatile process to be satisfied for the STT-MRAM architecture. This STT-MRAM architecture mainly based on writing operation with low power consumption for the writing architecture and to reduce the writing process compared to the existing leakage power. The noise analysis process mainly for satisfied for the STT-MRAM based cache architecture designs. This satisfaction mainly for not use the VDD connection and uses for the data storage enabling sensing process architecture results. Then to run the STT-MRAM architecture designs. Then the STT-MRAM architecture designs to mainly used for based on our the data input and the data selection process. This is our timing diagram results for overall architecture results. Whenever the data to be occur for the process, the clock to be activation for the signal. Then to writing was one to set the read the input data results for our the writing one activation function and to control the QOut function for the STT-MRAM architecture results. These are the architecture result to apply the overall STT-MRAM architecture process. This STT-MRAM designs to be activation for writing and the reading process for the overall final output results. STT-MRAM architecture.